Good morning, everyone. Today we learn about the topic random variables. Random variables is a real valued function defined on each and every outcome of the sample space that are connected with a random experiment. So what about random experiment? Random experiment is an experiment that is performed in an homogeneous conditions, and the outcomes of the random experiments are known earlier, but the prediction of the particular outcome is not possible. Then those experiments are termed as random experiments. And here we are learning about random variables. It is a real valued function that is defined on the samples or the outcomes of the random experiments. So another definition is a random variable is a function that is x omega with the domain S, and the range of the random variable is minus infinity to plus infinity, such that for every real number a, every real number is the random variable may takes the every real number. The range is minus infinity to plus infinity, and even the notation is minus omega, that is defined x of omega which is less than or equal to a belongs to Borel field. Borel field is nothing but the sample space. The sample space is the possible outcomes of a random experiment, and that sample space subsets is it is Borel field. So here we see the triplet SBP, which is called the probability space, where S is the sample space where we have all the possible outcomes of the random experiment, and B is the Borel sigma field. It is the subsets of all the sample space, and P is the probability function defined on the sigma field. We consider an example of random variable. If we want a random experiment is just tossing a coin. If we want to define a variable consisting of the which defines on the outcomes of tossing a coin, that means if we example we see here, if we want to know or if we want to give an random experiment x, random variable x, which is defined on the outcomes of tossing two coins. So the sample space will be HH, HT, and TH and TT. So the X is a random variable which takes the values of number of heads. It can be explained below. That means if the random variable takes defined on X, HH, we get, since there are two heads here, we have the value of X takes 2. In the second outcome, it is HT, that is only one head. The number of heads over that outcome is 1. So the value of X takes 1. In this third outcome, we see tail head. That means the value of head, the number of head in this outcome also is 1. So the value of X again takes the value 1. So, but in the last outcome, it is tail. There is no head over here that is in this outcome. So the value takes the value is the X takes the value 0. So all the possible values that the random variable X takes is 0, 1, and 2. Even though there are 4 outcomes over here, but the value of X takes only 3 values, that is 0, 1, and 2. We have different types of random variables. One is discrete and one is continuous. Discrete random variable. It is a random variable if the random variable takes at most countable values. That means only particular. As we see here in the example of tossing two coins, the X only takes the counted values 0, 1, and 2. And the values between 0 and 1 or 1 and 2, it doesn't take. That means 1.5 or 0.7, that like that, the values doesn't take. It takes only the at most countable values. That means only 0 and 1 and 2 only takes. Then those random variables are termed as discrete random variables. Examples, we have number of heads in tossing of 3 coins, number of birds in a city, exam, etc. So if a function defined on this random variable, discrete random variable, then it is known as probability mass function. For example, let us consider x is a random discrete random variable which takes the value or assumes the values from x1, x2, x so on xn with respect to the probabilities p1, p2, so on pn. In general, the PMF is defined as pi or p of x is equal to xi. So, if I want to say some function is a probability mass function, then it must satisfy these two conditions. That means if we take the individual value of the probability for any value of x, that means x1, x2, and so on xn. If I take the probability of that, it must be greater than or equal to 0. That means only the positive values, including 0 takes. There is no negative value over here. For all I, if the I ranges from 1 to n, and all the possible, the probabilities of all those individual probabilities must be greater than 0. And for n equal to I ranges from 1 to n, and when we add up all the probabilities, it must be equals to 1. Then we say if these two conditions are satisfied, then we say that function is a probability mass function for a discrete random variable x, which takes only the countable values. And next we have continuous random variable. Continuous random variable is a random variable that takes all the possible values between certain limits. If I say the weather of a particular city, that means the weather in summer, if we take, means the weather of Vijayawada, for example, it may ranges from 30 plus to 35. That means even 30 to 35, all the possible values it takes between the limits 30 and 35 degrees. That means even it may take 30.5, 33.2, 35, 34.7, all these ranges between those limits. Also the value of x takes. When we consider x as a x defines about the temperature of a weather condition of a city. So if a random variable takes all the possible values between certain limits, then it is known as continuous random variable. So when a function defined on continuous random variable, it is denoted by f of x, and we can say a function is PDF or probability density function if it satisfies two conditions. That means f of x must be greater than or equal to 0. The x ranges from minus infinity to plus infinity. That means individual functions, when we define probabilities over them, that individual probabilities or the functions of individual x values taken individually must be greater than or equal to 0, and the limits ranging from minus infinity to plus infinity, when we integrated them all, when we apply the limits, all the limited value or the range that has given the x takes, it must be equals to 1. Or if an event takes an interval between a and b, and it is calculated by integral a to b f of x. So we also have a distribution function for a random variable, and it is denoted by capital Fx of x. For a we have some formula for both discrete random variable and continuous random variable. For discrete random variable, it is p of x less than or equal to x. Say here we see the upper limit is x, only the till x only it takes, not plus infinity. So the range is from minus infinity to till x, since the x is uppermost value. So the value it takes minus infinity to summation ranges from minus infinity to x, p of x equal to x. The p of x is equal to x is nothing but the probability function. For a continuous random variable, it is the integration ranges from minus infinity to x. Since it is not plus infinity, cause x uppermost value is till x only. So it takes the range of x is minus infinity to x. When we integrated it, it is the formula of distribute function. This is about a small topic, random variables. We have what we have discussed is types of random variables, that is discrete and continuous, and the functions over random variables, discrete and continuous. So a function defined on discrete function, it is probability mass function, and we see when we say a function is PMF, it must satisfy two conditions, that is individual probabilities must be greater than 0, and when we apply all the values of x and when we add up all the probability values, it must be equals to 1. Similarly, in continuous random variable, a function is said to be probability density function only if it is satisfies two conditions, that is one is individual f of x must be greater than or equal to 0, and when we apply the limits in a continuous random variable, when we integrate them, it must be equals to 1. Thank you.